So today we're going to talk about a general way of accessing all containers using a very similar interface in C++. So far you've seen a couple different containers. You've seen std_map, std_array, and std_vector. You've also seen how to iterate through these using the ranged for loop, as well as sort of what that translates to, at least in the case of a vector. But you can also do this with a map, and in that case, what does it mean? What does that translate to? How would you write that without the ranged for loop? Well, the answer is a standard, generic interface called iterators. They're C++'s way of exposing a general container interface without exposing the details of exactly which container you're using. In this view, imagine the shape is a container. Then the red box around A is an iterator acting as a view into that element. Iterators contain the information necessary to access the element that they're pointing to, as well as information necessary to get an iterator to the next element in the container. You should be able to go through all of the elements in the container using iterators. That's where they get the name iterators. The type of an iterator is a bit unwieldy. It looks like the type name of the container, : iterator. In general, people will usually use the keyword auto. If you don't remember how this works, check out the video from the first week that explains it. Alright, imagine that this is a container. You can get an iterator to the first element in the container using container.begin. You can also get an iterator to the special element called the end element using container.end. This element exists outside of the container and doesn't point towards an actual entry. So if you try to use it to get the entry that it is pointing to, it'll be undefined behavior. It's used to mark something that's outside of the container or past the end. So, for example, the next element of the last element in the container will be the end. Iterators also can be changed to the next iterator using ++. So that would make it point to B instead of A. You can also use the value at an iterator using the Dereference Operator, the star. So in this case, we're printing out the value at the entry pointed to by it. Here's another example with a more particular focus on vectors. So here, an iterator could represent the index in the vector that you're actually using. You can iterate through it and change values. You can also write a for loop that looks pretty similar to what we've seen earlier. Here, the end element represents the size index. So, for example, this vector is 6 elements long. The end element would be index 6, or equivalent to that. When you change a container by adding, removing, or moving around elements, any existing iterators will be invalidated. For example, if we move B and delete it from the container here, things might move around a little bit. A container is allowed to move items around once you add or remove elements in any way that it wants, which completely invalidates any iterators that you're holding on to during that operation. So, make sure that you never hold on to an iterator for longer than you are able to prove that it is valid. Let's look at some real code. So first I'm going to create a vector containing the integers from 1 to 5. Then I'm going to iterate through it using iterators. Remember the pattern. You grab the beginning, you check against the end, and each step along the way you increment to the next iterator. Now we can grab the value at each iterator using the Dereference Operator. You should remember this from earlier as well. Now running this, we'll be able to print out each value from 1 to 5. And there we go. So, you can also use the Dereference Operator to mutate an item in place. So for example, here we're going to use it to add 4 to each item in the vector. This actually changes the item in the vector. It's not temporary. Now we're going to work with maps for a little while, because that's a little bit more interesting than vectors. Now we're going to create a map with key 1 pointing to 5, key 3 pointing to 4, and key 2 pointing to 6. These are just random values I came up with. Now we're going to create a for loop again, grabbing the beginning iterator, checking against the end at every step, and incrementing to get the next iterator. Now we can use the arrow operator to do 2 steps at once. The dereference, and the dot. We can grab the first item of the pair, that'll be the key if you remember from the maps video, and the second item of the pair. When we run that, we should get a printout of the whole map. Now here I forgot to include the map header file, so obviously that's going to give some errors. Let's just add that really quickly. And run it again, and we should get a printout of the whole map. Great. Now, earlier you should remember the find function, which returns something. Well, what it actually returns is an iterator. It'll return end if it's not in the map, or it'll return an iterator to the correct entry if it is in the map. Here we're going to print out the value if the key 1 exists in the map. Of course it does, so we should see 5, and we do. There's another function that we learned that had some interesting syntax the first time we saw it. If you remember, the erase function to remove something from a map had to be called with a parameter of find. That's just because it takes in an iterator of the item to remove. So here we're going to call erase with it only if it exists in the map. And now we can just simply iterate through the map again to prove that it has in fact been removed.